Okay, we did this one in class, but let's quick write this up here. So, when you have a resistor circuit like this and you ask for the current to come out of the battery, all right, what we're going to do is find the equivalent resistance first. So, Req, we're going to take this circuit and convert it into its equivalent circuit, which is just one resistor with a battery of 9 volts. All right, so with the series circuit, you just add them all together. 20, 30, 45. All right, so we know that's 45 ohms. And then we can use Ohm's law to figure out current supplied. The voltage of the battery is 9 volts. So we got V equals IR, which can be written as I equals V over R, or R equals V over I. Whatever way is most useful is what we're going to use. So I equals V bat, this is I sup, V bat divided by Req. So 9 volts divided by 45 ohms. 9 over 45 is like let's just get this right. We just did it in class, 0.20 amps. So that's your I supply. And in a series circuit, I supplied equals I1 equals I2. All the current has to be the same because there's no branch off. So you have no junctions, so the current has to be the same everywhere, which equals 0.20 amps. No further calculation needed for that. The voltage across each resistor. Well, now we know, so V1, I should have I3 in there as well, but whatever. Sorry, added that. V1 is going to be I1 R1. So we're just going to use Ohm's law for each resistor. It's going to be 0.20 amps times 20 ohms. That one's going to be 4.0 volts. V2 is going to be I2 R2. So we just apply Ohm's law to each individual resistor now. 0.20 amps times 10 ohms is 2.0 volts. V3 equals I3 R3. So that's 0.20 amps times 15 ohms, or 3.0 volts. And immediately I know that this must be correct because they add up to 9. The rule is, in any closed loop in a circuit, delta V has to be 0. So you gain 9 volts, or another way to say it is V bat has to equal V1 plus V2 plus V3, and 9 volts equals 4 volts plus 2 volts plus 3 volts. It works out, checks out, right? Works out nicely. Works out nicely. All right, that equals 9 equals 9. Power in the 10 ohm resistor. So we just got to pick power equals current times voltage, which if we plug in Ohm's law for voltage, we'd get I squared times R. If we plugged in for V, V equals IR. If we plug in for I, we get V squared over R. So we just got to pick which version of the power equation we want to use based on what we're given. So in the 10 ohm resistor, we know R, we also know V, we know I, we know V. The easiest one is if you know I and V, let's just use that. So we already did all that work, so let's just go ahead and use that. Power equals current times voltage, so the current is 0.20 amps. The voltage across the 10 ohm resistor was 2 volts. So you get 0.40 watts. Volts times amp is a watt. And I could have done the other math as well. If I had done this one, it would have been 2 volts squared is 4. The resistance is 10. 4 over 10 is 0.4. All right, next series circuit. 3 amp flows out of the battery, so that's our I supplied. 0.03 amps, very good. What must R be equal to? Well, okay, let's look at the equivalent version here. So 12 volts and REQ. Oh, it's a terrible circuit, but REQ. We're looking for I. But we also don't know REQ. But REQ we can get really quick, right? REQ is the sum of these, so it's 2R plus R plus R equals 4R. This is kind of a fun little algebra trick here. Okay. 4R is the equivalent resistance, so the current, oh look, I already know the current. What am I doing? 0.03 amps. I don't know why I wrote down question mark. Oh, cool. So now I can just do, okay, REQ must be, I'll use this version of Ohm's law, VBAT divided by the current supplied, right? That's your VBAT there. So 4R must be equal to 12 volts divided by 0.03 amps. Divide both sides by 4. I guess I could do that math first, right? But, all right, so I'll do 12 over 0.3, which is 400. Or, wait a minute, 02 amps. What am I, no, 03 amps. So it's 600. What did I do here? Did I do this wrong in class? I must have. Whoops. 600 ohms, volts per amp. No, that's not right. 0.03, 400. I did do it right in class. Jeez. 12 divided by 0.03. 400 divided by 4 equals 100 ohms is what R would be equal to. So that one would be 200 ohms, this would be 100 ohms and 100 ohms. Very good. All right, on to parallel circuit, or another series circuit, okay. Whew. In the circuit above, battery provides 9 volts. The first resistor has a potential difference of 2 volts, second resistor 4 volts. What must the potential difference across the third one be? So V3, okay, so they must all add up to 9 volts. So let's set up, I know V3 has to equal 3 volts, but let's show the work here. So 9 volts has to be equal to 2 volts plus 4 volts plus the unknown V3. So 6 here, bring it over here. You get 9 volts equals 6 volts plus V3 minus the 6 volts minus the 6 volts. V3 equals 3 volts. Okay, if a second resistor has a resistance of 8 ohms, what must the current flow in the circuit be? Okay, so the second resistor, R2, is 8 ohms. We already know V2 is 4 volts. So let's find I2. I2 must be equal to V2 over R2. Apply Ohm's law to that resistor. So that's going to be 4 volts divided by 8 ohms. That's going to be 0.50 amps.
I delivered your child.
Thank you. Hey, I'm just recording a video, so. Oh, you're okay, you're okay. You guys are good. 0.5 amps must be I2. And in the series circuit, I supplied equals I1 equals I2 equals ... So they all equal 0.50 amps. Using the current from part B in Ohm's law, determine the resistance of the other 2 resistors. So R1 is equal to V1 over I1. So 2 volts divided by 0.5 amps. That's going to be 4 ohms. R2 is V2 over I2. Oh, we already did that one, so let's just do 3. R3 equals V3 over I3, so V3 we figured out was 3 volts. I3 is 0.5 amps. They're all the same in a series circuit. 3 divided by 0.5 is 6 ohms. Cool. Very good. And then that one was 8 ohms. And that makes sense, right? The biggest resistor, this was our 8 ohm resistor, has the biggest voltage drop. They drop in proportion. Very cool, very cool. This one here, total current in must equal total current out. So we have total of 9 out and only 6 in. So we must have another 3 amps going in. So total in has to equal total out. So I in equals I out is what you could say there. So current in equals current out. Must be 3 more amps in here. We got 9 in, 3.7 out. We must have another 5.3 amps flowing in. Here, in we've got 3.2 plus 0.8, so that's 4, plus another 2, that's 6 going in. That junction, we got 1 going out here, 1.5, so 2.5 out. So right now we have 6 in, 2.5 out, so that must mean there's another 3.5 amps going out of this branch. Conservation of charge, basically. Charge flow rate is conserved. All right, now on to the parallel circuits. All right, so parallel circuit shown above, voltage drop across each resistor. So in a parallel circuit, V bat equals V1 equals V2. All right, so they're all 1.5 volts. All the voltage drops are the same. Determine the current flow through each resistor. So we know I1 is going to be V1 over R1. So 1.5 volts divided by 10 ohms, that's going to be 0.15 amps. I2 equals V2 over R2. 1.5 volts divided by 15 ohms. That's going to be 0.10 amps. Great. Determine current flowing out of the battery. So look, this is a junction right up at the top of that circuit, right? I'm not going to draw the whole thing. All right, so this is your I in, which is your I supplied. It's breaking into I1, which is 0.15 amps, and I2, which is 0.10 amps. So that must have been 0.25 amps. So I supplied. So in a parallel circuit, the supplied current gets split up into however many resistors you have. So I supplied equals I1 plus I2 equals 0.10 amp plus 0.15 amp is 0.25 amps. Determine the equivalent resistance of the circuit. We have 2 different ways to do this. All right, you could do REQ equals V bat divided by I supplied. So it could be 1.5 volts divided by 0.25 amps. That's going to be 6 ohms. Or we could do the math from the other way. You could say 1 over REQ equals 1 over R1 plus 1 over R2. So that's 1 over 10 plus 1 over 15. 1 over REQ equals 2 over 30 plus, 3 over 30 plus 2 over 30, which is 6 over 30. And then we take the inverse, REQ equals 30 over 6 ohms or 5 ohms. Oh, geez, I did that backwards. 30 divided by 5. I remembered it as soon as I said the answer, because I remember it being 6 ohms from class. All right, very good. Determine the equivalent resistance of the circuit. Now, since I don't know the current here, I gotta do it with this. And what I'm gonna do is I'm gonna show you in the calculator. So I know 1 over REQ is gonna be equal to 1 over 10 plus 1 over 15, plus 1 over 30. Now, again, these are good numbers. And you could put the signs on there. In fact, you should in the regions. You really should put the numbers on there once. All right, so 1 over 10 plus 1 over 15 plus 1 over 30. That's going to end up being, well, you could do the common denominator. But I know what I'm going to do in the end is I'm going to do REQ equals 1 over all of that, right? 1 over 10 plus 1 over 15 plus 1 over 30. And that's exactly how I'm going to put it in my calculator. So I'm going to do 1 divided by, parenthesis, 1 divided by 10 plus 1 divided by 15 plus 1 divided by 30, and I get 5. And that makes sense to me, just because it seems like a reasonable number because it's less than 10. Determine the current supplied by the battery. Okay, so we go to our equivalent circuit. All right, this is 12 volts. This is 5 ohms. We're looking for the current supplied. I supplied, I equals V over R. So it'll be BAT divided by REQ. So 12 volts divided by 5 ohms. 12 over 5 is 2.4 amps. 2.4 amps. So that's a good problem there. I like that one. All right, we're getting to the home stretch here. Hairdryer uses 100 watts of power while plugged in to 120 volts. Determine the resistance of the hairdryer. So power equals 1600 watts. Voltage equals 120 volts. Now, let's reference the equation sheet quick. So I know power and volts, power and voltage, I'm looking for resistance. So let's see if there's an equation that we could use directly on our reference table to get that. Power equals current times voltage, okay. Well, no, that's not gonna be, I guess I could figure out the current using power and voltage and then find out the resistance using Ohm's law. Definitely a valid way to go. But what I'm gonna do is use a different equation. I'm gonna use this equation. Power equals V squared over R. All right, I'll be able to solve for R. So we can rearrange this a bit. V squared over P. So 120 volts squared divided by 1600 watts. All right. So let's see what we get. 120 squared divided by 1600. R equals 9 ohms. Very low resistance. Determine the current flowing through the hairdryer while on. Okay, I equals V over R. So that's probably what we want to do now. So 120 volts divided by 9 ohms equals 13 amps. That's why you need a 20 amp circuit in your bathroom. They draw a lot of current, the hair dryers. All right. So amount of energy used in 5 minutes of use. We've done this one before. Energy equals power times time. So it's 1600 watts, which are joules per second. I like to write it in terms of joules per second because then when we do our conversion, joules per second, and 5 minutes, so we got to go from 5 minutes, so it's going to be multiplied by 5 minutes, but we got to convert minutes to seconds, so it's 60 seconds per minute. Minutes cancel, so we get time of seconds in here, so it's 300 seconds times 1600 joules per second. That's 480,000 joules. A lot of energy. Now this next one's a bit of a challenge question, a little higher level than what I would ask you here, you know, I'm basically going to give you a series circuit, a parallel circuit, and, you know, a few one-off questions about resistance and power. So I'll keep it pretty straightforward, but this is a pretty good one. 3 identical light bulbs is wired shown above. Each bulb uses 60 watts of power while operating at a potential difference of 120 volts. Part A, determine the resistance of one of the bulbs. So when operating at 120, that's how much power they use. That doesn't mean they are all operating at 120 here. In fact, they're not, because the current, the voltage has to get split up in these loops, right? So these are each going to be operating actually at 60 volts. We'll see in a second. All right, determine the resistance of one of the bulbs. R equals V over I. That doesn't really help us. We actually have to go back and use the power equation again. So power equals V squared over resistance. So then we say resistance equals V squared over power. So 120 volts squared divided by 60 watts. So we're gonna get pretty big resistance on this one. 120 squared divided by 60 is 240 ohms. That's the standard value for these kind of light bulbs. Now, rank their brightness. That's an interesting question. Brightness. Brightness is proportional to their power. Brightness is proportional to their power. Brightness is directly proportional to the power. All right. How much power they're dissipating in the circuit. The more power is dissipating, the brighter it's going to be. So let's go ahead and calculate their powers, and then think about that for a minute. They're actually not going to be operating at 60 volts. I was not correct. These ones are going to have less current flowing through them than A, right? So whatever current's flowing, A is going to have all of it. So brightness from brightest to dimmest. So let's figure out the power of A. Let's just do it down here. Power of A equals, we know their well, we know they're all the same resistance, and I just talked about the current. I know that I through A has to equal I through B plus I through C. I know that IB has to equal IC because they're both the same. So the current through either one of these is going to be half of the current through A. So look at the equation. Power equals I squared times R, right? Power equals I squared times R. So whatever one has the most current is going to be using the most power because they're all the same resistance. So IA is brightest, is greater than IB, which is equal to IC. So therefore, power of A is greater than IB, or power of B, sorry, which is equal to the power of C. Again, this is above what I would ask you, but it's kind of interesting to think about. What would happen to the brightness of A and B if bulb C were removed, leaving the spot open? Okay, so if we go down now, all right, and we just go to 2 bulbs, well, what's going to happen is the current is going to go down. I supplied is going to go down, all right? So A would get dimmer. It would get dimmer because it has less current. All right, less current. A now only has a smaller amount of current than it did before. Now B though, B we have to think about. We would have to do a little more calculation work for B. I'm gonna do that offline because I don't think it's beneficial for this video at this time. So I'm gonna do that and it'll be in the posting.